Good morning, my dear students. Welcome to today's online class. We know in modern physics total 3 chapters are there. The first chapter means dual nature. Its weightage is 5 marks. And second chapter means atoms. Its weightage is also 5 marks. And third chapter, important chapter, a nuclei. Examination point weightage is 6 marks. 5 marks our problem is compulsory. Plus 1 mark question is also compulsory. So that is the importance of weightage of this chapter. In the chapter nuclei, first we should know the definition of the nucleus system. In previous atom chapter we know, a Bohr-Saturn model explains it. So what is the definition of nucleus system? So nucleus means, for example, it is atom. So nucleus means it is the central portion of every atom. So it is the central portion of every atom where almost entire mass of the atom is concentrating and the entire positive charge is also concentrating. So almost mass of the atom is concentrating and the entire positive charge of the atom is concentrating. So that portion is called as a nucleus effect. Experimentally we know the size of every atom is in order of 10 power minus 10 meters. Our size of atom is also expressed in terms of angstroms. 1 angstrom means 10 power minus 10 meters. At the same time, compared with the size of atom, the size of the nucleus is very, very small. Generally, size of nucleus expressed in terms of Fermis. Fermis. 1 Fermi means 10 power minus 15 meters. So size of the atom is angstroms and size of the nucleus means Fermis. So that is about size of atom and size of nucleus system. Now comparing to size of nucleus, size of atom is how many times more? So check the ratio of size of atom to size of nucleus. Size of atom is 10 power minus 10 meters and size of nucleus is 10 power minus 15 meters. A simplified meter cancel. A 10 power minus 15 is moving upside 10 power plus 15. So 10 power minus 10 plus 15 is equal to 10 power plus 5. So the ratio of size of atom to size of nucleus is nothing but 10 power plus 5 times. Or cross multiply size of atom is 10 power 5 times of the size of nucleus. So it is a relation between a size of atom to size of nucleus system. So that is about atom and the nucleus system. But nucleus is first discovered by scientist Rutherford. It is discovered by the scientist Rutherford in 1911. So that is about a definition of nucleus, relation between size of atom and size of a nucleus system. Next continuation concept, what about composition of nucleus system? So inside the nucleus, what is the chemical composition? Generally, inside the nucleus, protons and neutrons are there. And The sum of protons and neutrons are called as nucleons. The total number of protons and neutrons are called as nucleons. So that is about composition of nucleus. So inside the nucleus, protons and neutrons are there. The sum of protons and neutrons are called as nucleons are there. So that is about composition of nucleus. Generally, every nucleus is denoted by the symbol XZA. For example, X is the nucleus. Here Z means atomic number. A means mass number. So every nucleus is denoted by this symbol. Here Z means atomic number. And what is meant by atomic number? Atomic number related to number of protons inside the nucleus. So number of protons inside the nucleus is called as atomic number. Atomic number is always depends on number of protons. Number of protons is more, atomic number is more. Number of protons is less, atomic number is less. And A is called mass number is there. And we know mass number is also depends on the sum of protons and neutrons. And mass number is also called as the number of nucleons. The sum of protons and neutrons is also called as nucleons. It is also called as mass number. Total number of nucleons we know, and total number of protons we know. But how to find a number of neutrons are there? So number of neutrons is depends on A minus Z. A total number of nucleons minus number of protons becomes a number of neutrons are there. So here A minus Z represents the number of neutrons. So that is about composition of nucleus and representation of nucleus system. For example, you can consider one example. Find number of protons, number of neutrons, and mass number of nucleus. Of one nucleus is given as carbon 612. So in this example, carbon 612, how many number of protons, how many number of neutrons, and what is the total number of nucleons? So it is in the form of XZA. The given nucleus is in the form of XZA. Comparing these two, Z means atomic number, it is also called as the number of protons. Atomic number means number of protons. So number of protons becomes 6. And mass number or number of nucleons is nothing but A means 12. So by knowing number of protons and total number of nucleons, now find the number of neutrons. A number of neutrons means A minus Z. A minus Z means 12 minus 6. 12 minus 6 means 6. So that is about inside the nucleus, protons and neutrons are there. Sometimes, an example given. Find number of electrons inside this nucleus. Generally, inside the nucleus, protons and neutrons are there. But inside the nucleus, number of electrons becomes 0. According to Bohr-Schweitzer model, electrons are revolving around outside the nucleus. So in this example, number of electrons becomes 0. Also practice one more example. Again find the number of protons, number of neutrons, and the number of electrons. In second example, nitrogen 714. In this example, find the number of protons, number of neutrons. Again, it is also the form of XZA. Now compare The number of protons means atomic number. So atomic number means ZL is 7. So 9740 number of protons becomes 7. And mass number means total number of nucleons. And A value becomes 14. So total number of nucleons is number of protons will. Now calculate the number of neutrons. Nothing but A minus Z. Here A means 14. Z means 7. 14 minus 7 means 7. So that is about composition of nucleus and a representation of a nucleus. Next continuation concept, the classification of nucleus. All the nucleus are classified into different types. The first kind of classification is isotopes. So what is meant by isotopes? Here iso means same. Topes means number of protons. So isotopes means the nuclei which are having same number of protons, but different atomic number, but different mass numbers. So that is about isotopes are the nuclei which are having same number of protons, but a different mass number. That kind of classification is called as isotopes. Generally, every element having different isotopic forms are there. For example, what is isotopic forms of hydrogen? Every element having different isotopic forms. What about isotopic forms of hydrogen? Hydrogen having 3 isotopic forms. The first isotopic form of hydrogen is 1H1. Second isotopic form is 1H2. And third isotopic form is 1H3. So these are the 3 different isotopic forms of hydrogen. But compare all the nuclei having same atomic number, same number of protons, but different mass numbers are there. So that is about one example of isotopic form of isotopes of hydrogen. Next, one more example is helium. What are the different isotopic forms of helium? Helium having 2 isotopic forms. One is nothing but helium-2,3 and other one is nothing but helium-2,4. These are the 2 isotopic forms of helium. Here also, both nuclei having same atomic number, same number of protons, but different mass numbers are there. Then such kind of classification is called as isotopes are there. Next, one more. Nitrogen. What are the different isotopic forms of nitrogen? One is nothing but nitrogen 713. Second one is nitrogen 714. And third one is nothing but nitrogen 715. So these are the different isotopic forms of nitrogen. But compare, all are having same atomic number, same number of protons, but different mass numbers are. So that is about the first classification of nucleus means isotopes are there. The nuclei which are having same number of protons, same atomic number, but different mass number. That is about first type of classification means isotopes. Next, second kind of classification means isotones. What about isotones? Here also same. Here iso means same. Tones means a number of neutrons. The nuclei which are having same number of neutrons, the number of neutrons is same, but different atomic number and different mass number, then such kind of classification is called as isotones are there. So total in case of isotones, all the nuclei having same number of neutrons but different atomic number and different mass numbers are there. So that is about the second kind of classification is isotones are there. For example, carbon 613 and nitrogen 714. These two are called as isotones. How we can say these two are called as isotones? For example, in first carbon 613, here number of neutrons means we know formula for number of neutrons means A minus Z. Here number of neutrons means 13 minus 6. So 13 minus 6 means 7. Here in nitrogen 714, how many number of neutrons are there? Here also number of neutrons means a formula means A minus Z. 14 minus 7 means 7. In carbon 613, number of neutrons is 7. In nitrogen 714, number of neutrons is also 7. So the nuclei which are having same number of neutrons but different atomic number and different mass number, such kind of nuclei is called as isotones. And next, one more example, example 2. It is also one more example of isotones. For example, 1H3 and helium-24. 1H3 and helium-24, these two are also called as isotones. How means, once again check. In 1H3, the number of neutrons means A minus Z formula 3 minus 1, 3 minus 1 means 2. So here 1H3 number of neutrons means 2. In helium-24, here also number of neutrons means 4 minus 2. 4 minus 2 means 2 is there. So in 1H3 and helium-24, both are called as isotones are there. The nuclei which are having same number of neutrons but different atomic number and different mass number. So such kind of classification, second kind of classification is called as isotones. Next, what about third kind of classification? Next, third kind of classification means isobars. What about isobars? Isobars means here also iso means the same. Bars means mass number. The nuclei which are having same mass number but different atomic number, then such kind of classification is called as isobars. So total in case of isobars, two nuclei which are having, different nuclei which are having same mass number should be same, but different atomic numbers. So such kind of third classification is called as isobars. What is the example of isobars? One example of isobars. For example, 1H3 and helium-23. These two are called as isobars. How? Because these two nuclei having same mass number but different atomic number. The nuclei which are having same mass number but different atomic number, those kinds of nuclei is called as isobars. Next, one more example. One more example of isobars means carbon 613 nitrogen 730. These two are also called as isobars because these are having same mass number, the nuclei which are having same mass number, but different atomic number. So different atomic number, but mass number should be same. Atomic number different means the chemical nature of element is also different.